Okay, so now what I'd like to show you is the joystick controlling the servo motor. So allow me to bring up the code to show you this. So let's share the screen. And first we'll look at the code for the sketch. All right, so here's the sketch code for the joystick controlling a servo. Now before I do anything, let me just go out to the tools, make sure I have my board selected and my COM port selected. I'm going to just compile this code and download it to my board, and I will talk to you about what is this code doing and then show you exactly what it's doing. While this thing is compiling, let's take a crack at explaining some of the things here. So this code is a little bit different. The very first thing here says # include, and inside in between a less than sign, greater than symbol, we're making reference to a library, servo.h. It's a library that has additional functions that were pre-created that has something to do with the servo motor. So this # include says, bring into this sketch any libraries, the library that has functions that are specific to a servo. So we can use those functions by calling the function names in this code simply by using this include statement. Finally, our sketch uploaded successfully. There's a couple of integer variables defined here, but they have a keyword in front of them called constant. So these are integers, they're whole numbers, one representing the pin we're using for the servo, and 0 representing the potentiometer, which is the value that we're reading in. How do we define that? We're going to be using the potentiometer, which should be connected to analog pin 0. So this could either be 0 or A0, but this is the potentiometer, and it's going to be connected to the analog pin A0. And these values don't change; they remain constant. Hence the keyword constant. Here's the keyword we're using: the word servo, which is the library, and we're referencing a variable of type servo, and we're calling it myServo. So anytime we want to reference a function that's in the library for the servo, we create a variable of that library type. The name of the variable is myServo, and anytime we want to invoke a function from that library, we use the name myServo dot whatever the name of the function is. Here we have an integer for a value with 0 and a time delay of 150 milliseconds. So here in our void setup routine, we have the name myServo, which is an object of type servo. Therefore, we're allowed to reference any of the functions in its library. And we're going to access a function called attach. I know that this is a function because it's color-coded orange, and it takes one positional argument, which is the capital word servo, which means pin 9. So what this is saying is that we want to look out on pin 9. That's where we're going to be connecting our servo to, physically to pin number 9. We'll see that in a minute. So repetitively, what are we going to be doing? We're going to be doing the analog read off of the A0 pin. That's what pot is pointing to, 0, which is really A0. And the value that we're reading in from the analog read function is going to be assigned to a variable called val. Then what we're doing is we're going to use another function that's a math function called map, and it takes 4 positional arguments. The first positional argument is the value that we're reading in from the analog pin, which was pin A0. So we have a value that's returned from that analog read function, and it's the first of 4 variables in this map function. Okay, we have a 0, and this is actually 5 positional arguments. The value is the first positional argument. The second and the third positional argument are 0 and 1023. That gives us a range of values, 1024 or 1K number of potential values. The last 2 values, the fourth and the fifth arguments to this map function, says we want to take the second and third variables, the 0 and the 1023, and we want to map the numbers and translate it into a range from only 0 to 179. So make a long story short, from 1024 potential values, we're going to transform that into a potential of 180 potential values. And that's going to be the result of this map function to basically return a value that's mapping from 1,024 possibilities down to 180. So basically each step of the 180 steps, if we have an interval of a certain amount, we can have 180 possible values that would equate to the 1,024 overall values. And what we're actually measuring here is the delta of the amount of voltage we're reading in. And then the next statement says, let's do a write out to my servo value. And basically what this value is doing for us is it's changing the position. Actually, that's what it's doing. It's changing the relative position. So it's reading the potentiometer, not the voltage. It's reading the potential. Well, technically, yes. It's reading the potentiometer to see the angle that we want. And instead of 1,024 possible angles, we're actually saying we want 180 possible values so that we can change the relative angle of how the potentiometer is pointing. And we're doing a write function with the value argument on the servo to position the servo to that spot. And then we're waiting for a duration of time. And then this is basically repeating. Let's first step out and look at a couple of these functions for a little clarity. So before we look at the document camera, let's go out and let's examine some of the code that we have from the Arduino reference library. So here I just went to www.arduino.cc/reference/en/libraries/servo, and it brought me to this screen. Okay, so what we have here in this reference, it's a library, and specifically we're looking at the Servo library, and the Servo allows Arduino boards to control a variety of servo motors. That's basically what's going on here. As you see here, there's a whole bunch of functions and variables and structures and library information here that we can reference. Let's take a look at the next screen that we want to share. Again, we're going out to the Arduino CC reference. This time what I want to do, I want to explicitly look at the information regarding the attach function. And we can clearly see that we're attaching the servo variable to a specific pin. And the syntax is servo, which is the function, dot attached to specific pin number. So an example of this is basically what we have here. # include servo.h. Look at the servo library. Define a variable. The name of the variable is my servo, and it's of type servo. So in our setup routine, we can actually say our object variable, my servo, attached to pin number 9. So now we know that the servo is physically attached to pin number 9, and we can do something with that. So what are we going to do? We're going to do an analog read. So let's take a look at that function. So here's the analog read function, and the analog read function reads a value from a specific analog pin, right? So before we do anything else over here, okay, so the analog read function reads a value from a specified analog pin, all right? What's going on here? The Arduino board contains a multi-channel 10-bit A to D or analog to digital converter. This means that it will map the input voltages between 0 volts and the 5 volts that we operate at, and it will convert that into an integer value between the range of 0 and 1,023. There's 1,024 possible different values that we can have between 0 and 5 volts. So on an Arduino Uno, for example, this gives us a resolution between readings of 5 volts divided by 1,024 potential divisions, or it gives us 0.0049 volts or 4.9 millivolts per unit or division. Okay, so that's basically what's going on here on the Uno board. And the last thing I wish to share with you is another function called the map function. What exactly is that doing? So it's taking those 1,024 potential, whoops, that's the wrong screen. Let's try that again. Let's go out to here and let's share the screen one last time. Let's look at the map function. There we go. So the map function, it basically remaps a number from one range to another range. So that is a value from low would get mapped to low, and a value from high would get mapped to too high. So if we were to take a look at something like that, let's see if we can find the syntax. So here's the map function. It has 5 positional arguments. We're going to look at the value that we have, and it's going to give us the low and high as our source, and our too low and our too high, which is our destination. So we're converting a number with the second and the third variable, that's the 0 and the 1023, and we're converting it to a different range from 0 to 179. So we're going from 1024 possibilities to 180. So that's how we get the slight little adjustments, and this allows us to then return the result of this syntax, which will give us a number, and we'll assign it to our value, and we'll then use that to apply that to the servo, which will change its position. So let's take a look at the code and see exactly where that was taking place. Okay, you can look at these functions to digest what I just said, which is pretty quick. So here we're doing an analog read of the analog pin for the potentiometer, getting a value. We're using the map function to translate the value into a new value with a smaller range. And then we're writing out to the servo to change the position. That's basically what's happening. So with that said, let's now examine the document camera and see how this behaves. So let's share the screen. Let's go to the document camera and let's take a look at what we have. Now, this Arduino board has 2 yellow wires here. One of the yellow wires is all that we need to go to analog pin 0 is really all we need. And that's going to the up-down part of the joystick. The A1 we really don't need, but I just used the board with the joystick from my previous example when I just had the joystick controlling forward, backward, left, right movements and displaying various LEDs. So that's why I have something erroneously not needed connected to A1. Other than that, the red wire from the servo is running to pin number 9, and then I have my one wire is going to my red bus, which is plus 5 volts, and one is going to my ground, which is going to 0 volts. Okay, so let's see how this thing works. I think we've already uploaded it, so let me just get this out of the way and let's see where I put it. So that's, there we go. Let's just put it right over here so that we can see how this thing works. Let's see how we're going to do this. There we go. Let's just push this up a little bit. Let's see which way would go up. Oh, that's going that way. So I want to go. Push this right here. Okay, so that's visible. All right. So now if I move my joystick, what did I forget to do? Let's see. I think I have everything wired here. Oh, I don't have this pin in the place. I had to disable that. So shame on me. Okay, I had to move the green wire into the middle pin. I took it out so this thing would not activate. I also included a switch here. So I want to show you that. I have a switch and I have it set up so that I have one wire of this 3-pin switch. Let me just take this out so you can see it. There's 3 pins here. And if I place this back in very carefully, the middle pin and the pin to the far right, the pin on the far right has a 100 ohm resistor connected to it. And I'll try to point that out. That's right over here. Okay. So with the switch pushed towards me to the far right, the middle pin and the pin on the far right is basically connected through a 100 ohm resistor back to pin 3 of the Arduino board. It's pulling in a 0. And if I leave that there and I move the actually I have that disabled, so X-nay, just ignore that fact. Okay, so when I move the joystick, if I move it up, I can move it in one direction, and as I move the joystick the other way, I can move it the other direction. So you can see how I can control, using the joystick, how I can change the motion of the servo. Now the trick's going to become, now that we can do that, when we release the position back to the essential part, how do we make it stay where we want? That's something we have to discuss. Okay. Okay, so that is the joystick controlling a servo motor.